uniformly accelerated linear motion by calculus method. That is, we are going to derive here position time relationship. S is equal to ut plus 1 by 2 at square. Dear students, you remember we have considered an object moving along a straight line, right, with uniform acceleration. What do you mean by uniform acceleration? Its velocity changes by equal amounts in equal intervals of time. ये आपको याद होगा, ठीक है ना? तो let's try to derive this very equation. S is equal to ut plus 1 by 2 at square by calculus method. Dear students, I will be using here the concepts of differentiation and integration, right? So you remember the definition of the velocity, that is rate of change of displacement. तो velocity में यहाँ पे लिखूंगा velocity here it is written as velocity rate of change of displacement. So let me write it here. It is equal to dx by dt, right? Rate of change of displacement. So from this very relation I can write this dx it is equal to v dt. बात समझ आ रही है ना? Just try to follow the steps, right? तो हमने ये इक्वेशन ऑलरेडी डिराइव की है. v is equal to u plus at. पहले लेक्चर में मैंने ये वाली इक्वेशन ऑलरेडी डिराइव की है बाय कैलकुलस मेथड, ठीक है? तो इस v के बदले में लिखूंगा v is equal to u plus at. So let's try to substitute it here. तो मैं लिखूंगा यहाँ पे dx it is equal to, हाँ खुद बताओ v के बदले क्या लिखूंगा? u plus at. Okay, okay, so it is dt here, right? Now let's try to integrate this very equation within proper limits. मैं यहाँ पे आपको समझाऊंगा limits of integration. For example, body is moving along a straight line, right? Let at this very point, for example, t is equal to 0. Okay, velocity is equal to u, I mean the initial velocity, and suppose x is equal to x naught, right? Now after some time, for example, at t is equal to t, after some time velocity is equal to v, that is the final velocity, and x is equal to x, that is some displacement x here, right? So let me use these limits of integration here. So let me integrate this very equation. I mean this is integral of dx, and limits of integration are from x naught to x, right? And here this is u plus at dt, and limits of integration are from 0 to t, right? Okay, let me integrate this. So what is integral of dx equal? It is equal to x, and limits of integration are from x naught to x. बात समझ आ रही है ना? Here I will use one property of the integration, that is integral of sum, it is equal to sum of the integrals. So I can write it here, it is u dt, limits of integration are from 0 to t, okay, plus at dt, again the limits of integration are from 0 to t. Now let's try to evaluate these integrals, right? Here I can write this is upper limit minus lower limit, so I will write it as x minus x naught, it is equal to, ठीक है ना, u इंटेग्रल के बाहर आ जाएगा, integral of dt is t, limits of integration are from 0 to t, okay, plus since acceleration is constant it will come out of the integral, and here it is integral of t dt. So what is integral of t dt? It is simply t square by 2, and limits of integration are from 0 to t. What is integral of x dx? That is simply x square by 2. ये rule of integration मैंने यहाँ पे use किया. So again I can write, so this is x minus x naught, it is equal to u. Here it is t minus 0, that is simply equal to t. So this is ut here. Plus a, let me write it at a by 2. So this is upper limit minus lower limit. This is t square minus 0 square. बात समझ आ रही है ना? So it is here x minus x naught, it is equal to ut plus, let me write it here, this is 1 by 2 at square. Okay, so let me repeat it here. This is x minus x naught, it is equal to ut plus 1 by 2 at square. Let me write s is equal to x minus x naught, where s is the distance or displacement, because distance and displacement here in this very case it is one and the same thing, because you know body is moving along a straight line, so displacement s and the distance, they are one and the same thing. So I have replaced s is equal to x minus x naught, so I can write it here. So s is equal to ut plus 1 by 2 at square, because the motion is linear motion, that is body is moving along a straight line. So this is how we derive the second equation of uniformly accelerated linear motion. S is equal to ut plus 1 by 2 at square. Simply I have integrated this very equation, velocity v, it is equal to dx by dt within proper limits. तो होप आपने ये वीडियो अच्छे से समझा होगा. थैंक यू वेरी मच.